So in this video, I'm going to recap the three measures of central tendency, which is mean, median, and mode. And then we're going to talk about standard deviation, which is a measure of the variability or the dispersion of the data. So starting off with the mean, we can calculate this as being the sum of all the observations that we have divided by the number of observations. So this is one of the most common ways of calculating an average. You can write this mathematically using these symbols here. So this one, the E-looking thing, is the sigma symbol in Greek, and it just means sum of. And then the xi, these are all our different observations. So I is just the observation number. So if I equals 1, it's talking about the first observation. If I equals 10, it would be talking about the 10th observation. So I'm just going to put observation here. And then on the bottom line, n is just the number of observations that we've made. So let's do a quick example of this. So let's pretend that the data that we have been given and we need to calculate the mean of is 16246. Okay, and we want to calculate the mean. So applying our equation, either version will work, the one in words or the one in symbols. I'll go with the symbolic one. So on the top line, we're summing together all the observations. So we need to add all these numbers together. And then we're dividing by n, which is the number of observations. So we've got 1, 2, 3, 4, 5. Alright, so if we add up the numbers on the top line here, I think it comes to 19. We've got 5 on the bottom line, and if we put that in a calculator, we end up with an answer of 3.8. So that's going to be the mean for that set of data, 16246. Alright, so one other thing to watch out for is we make a distinction about when we measure the mean, whether we're measuring of the overall population or of a sample of the population. So let's say that we have some population, alright, of people. And within that, if we want to measure what's happening within this population, say it was the population of Australia, it's probably going to be far too big to sample every single person or ask every single person what their value is for some particular thing. So this could be their maybe happiness or something on a scale of 1 to 10, or the likelihood of them doing something on a scale of 1 to 10. So rather than asking every single person in the population of Australia, we might just look at a sample of people, just to make that a more manageable process. So depending on which type we're looking at, whether we're looking at the population, so we've asked every single person, or whether we're looking at a sample, so we've just chosen a random number of people to ask, we make the distinction on how we express the mean symbolically. Okay, so if it's the population we're looking at, then we're going to use a Greek letter for it, and we're going to say that the mean is equal to mu. Okay. If, on the other hand, though, we're looking at the sample, we're going to say that the mean is equal to x bar. Okay, so that's really the only difference between whether it's a population or a sample, is just making sure that we use the correct symbol to express that. So that's pretty much all there is for mean. Alright, so the next one that we're going to talk about is median. And this one we can think of as the middle value when our observations are arranged in order. So let's do this one with an example as well. We'll use the same example. So we had 16246. So to find the median, we need to make sure that we start by arranging our values in order. So usually you want to go from lowest to highest. So if I rearrange these, it's going to be 1 is the smallest, 2 is next, then 4, this one shifts over, so 6 and 6. So what we're looking for now is the middle value in all of that. So if you count in the same number, so 1 here, 1 here, 1 here, 1 here, what we're going to find is the middle value in this example is 4. So that's what we would say is the median. Okay, now the catch is if we have an even number of values in our sample, so this one you can see has an odd number, all right, 5 different values, In that case, we need to have a slightly different method. So let me do the same example, but with one extra value. So 1, 6, 2, 4, 6. Let's pretend we have one more and it's the number 7. Okay, so again, if we want to work out the middle value of this, we need to start by rearranging our values to be in order. So it would be 1, 2, 4, 6, 6. This time we have a 7 on the end. And now when we look for the middle, okay, we have 1 on this end, 1 on this end, they cancel with each other, 1 on this end, 1 on this end, they cancel with each other. What we're going to find is that we kind of have two values that sit in the middle. So how we can get around that is we take the average of those two values using the method that we just looked at above. All right, so that means this time the median is equal to the sum of our observations, so that's the 4 and the 6, divided by the number of observations, so that's going to be 2. So we're going to get 10 divided by 2, which is the same as 5. Okay, so depending on whether we have an odd or an even number of values, we have to apply that slightly different rule. Right, so if we want to try and remember this, we can say if n is an odd number, like this first example was here, then the median value is just straight away the middle number. Okay. However, if n is an even number, we have that extra step. The median is the average, or mean, of the two middle numbers, as we saw. So that's pretty much all there is for median. So next one that we have is the mode. Alright, so the mode is just the most frequently occurring observation. So again, let's do our example, and we'll use the same one again. So the values that we've got are 1, 6, 2, 4, 6. So what we're looking for is the one that occurs the most frequently. So you can do this either using a frequency table. Otherwise, in our case, we've only got a little bit of data, so it's going to be quite quick to assess. So what we can see is that the value of 1, the value of 2, and the value of 4 each occur just once. However, the value of 6 here occurs twice. So what that means is that the mode for this set of data would be 6 because it's the most frequently occurring observation. And you can also apply this kind of methodology when you're looking at data which has been grouped into classes. It would just be then, instead of the mode, it would be the modal class. Okay, and we'll be looking at that a bit more in the future. So that concludes the 3 measures of central tendency. So all that we've got left is looking at standard deviation. So standard deviation measures the extent to which a group of observations differs from the mean. So another way of saying this is it's measuring the dispersion, or how dispersed the data is. So if something has a small standard deviation, that means that the data is quite well grouped. However, if it has a large standard deviation, that means that the data is pretty spread. Okay, so here it matters whether we have a sample or a population set of data. So if we have a sample, all right, this is the equation that we're going to use. Note that it's got n minus 1 on the bottom line. However, if we're drawing from the entire population, all right, so we've sampled every single person within it, that means that we can use this equation, and what you can see is on the bottom line it's got n. Okay, so that's where the difference is. Also take note of the symbol that's been used to denote standard deviation. So when it's sample data, we're using S, and when it's population data, we're using this one here, which is called sigma. It's another Greek letter. So what are these equations actually doing? Well, let's have a look at this one first. So what we're doing is we're performing another sum, so we're adding together, and what we can see in here is that we've got xi, which was our observation value from before, minus x bar, and remember that was the mean for the sample, and then all of this gets squared. Okay, so we're basically adding together the difference between our observation and the average, okay, for our sample data, and then it all gets divided by n minus 1. It's the same thing over here, so we're adding together for each of our observations the difference between our observation and the average one, or the mean one, for that population. Okay, and here is just the number of observations, except we're using a capital simply because it's population again. So let's quickly do an example again. So we've got our data of 16246, and let's assume firstly that this is sample data. Okay. So what we had before from when we were calculating the mean is we figured out that the mean was 3.8, and for a sample we call that x bar. Okay, so if we scroll back down, x bar is equal to 3.8. So now we just need to go through and apply our equation. So s is going to be equal to the square root. Now we have to add up all these. So we're looking at the difference between our observation and the mean one. So the first one is going to be 1 minus 3.8, and it gets squared, and then it's a sum, so we need to add the next one. So that's going to be 6 minus the mean, which was 3.8, and it gets squared, plus the next one is 2 plus 4 plus 6. Alright, so that becomes the top line, and then the bottom line is the number of observations take 1. So here we've got 1, 2, 3, 4, 5, so it's going to be 5 minus 1. So that's a bit messy, but if you type it into a calculator, what you should find is that the standard deviation of the sample comes out to 2.28. So that's the answer there. Alright, so now let's do the same thing, except we're going to assume that it's a population that we've measured from. So we go through exactly the same process. We need to figure out what the mean is. This time though, it's going to have the mu symbol, and it's going to be the same value though, 3.8. And we just need to go ahead and use our equation. So in that equation, the top line is exactly the same as what we have here, except that we're using a different symbol for the mean. So we should be able to just copy out what we had here. Cool, so that's that. And then on the bottom line this time, we have n, which is the number of observations. So we have 5, so that goes directly in here. And what we find is that the value, when you type all of that in a calculator, comes out to 2.04. So you might ask, why is this treated differently when it's a population versus a sample? And the reason is when you're dealing with a population, you've got the data for every single person that sits within it. Okay? Alright, so you've got every single person's stuff. Whereas when you're dealing with a sample, it's only a random portion of that overall population. So depending on who you pick in your sample, it may or may not be entirely representative of what's happening in the wider group. So as a result, when you go to estimate the standard deviation, when you're looking at a sample, you're going to estimate a bigger value than when you're looking at the population, which should give you a smaller value. And that's why there's just this -1 on the sample version, because you're dividing by a slightly smaller number. That means you should end up with a bigger value for the standard deviation. Now finally, rather than going through all of that on paper, you can also check what's happening in Excel. So if we jump over, I've put in my data here, and we're going to quickly calculate each of these different things and verify that we get the same value in Excel as what we get on paper. So, to get the mean, you type in equals to start an equation, and then the formula is average, or function is average. Highlight your data, hit enter. It's going to come out to 3.8, which is what we got before. For median, the function is median. Again, type it in, and then we just need to highlight the data and hit OK. And we get 4, which is the same as what we got before. With mode, the function is mode. Type that in, highlight your data, and it returns 6, again, which is what we expect. And now all we've got to do is the two different types of standard deviation. Alright, so for sample standard deviation equals to start a formula, and then the function is stdev, and then depending on whether it's a sample or a population, pick the appropriate one. So .s would be sample, and then highlight raw data, and we get 2.28 with a bunch of decimals. So that's what I rounded before to 2.28. Remember, if you do want to round, just go into format cells, and then you can change it to be a different number of decimals. And then for population, again, it's the stdev, and then we want the .p version for population. Highlight the data, and we get, this rounds to 2.04. Alright, which is what I had in the manual calculations. So that's all there is for this video, and see you in the other examples.